So we've talked about in the past, in the last video, that there's four main molecules: carbohydrates, lipids, proteins, and nucleic acids. Well, let's start out by talking about carbs. And everybody talks about carbs and they give carbs a real bad rap. But they're actually really good for us, and if they were gone, we would not be around, so we'd be dead. So carbohydrates are molecules made up of carbons, hydrogens, and oxygen. They're sugars. Anything that's a sugar, most of them will end with an OSC. So if you think about some of the sugars, like glucose, fructose, those are sugars, lactose, those are all different types of sugars. Glucose is one that we commonly talk about, and you're going to see us talk about it in our next unit number 2 or 3. Fructose is one that comes from fruit. It was sort of rare, but now that people are making fake sugars, this is a pretty common one, and our body kind of gets confused because we see it so much, and that's why people are getting fatter. So when they say that we're getting too much sugar, what they're really talking about is fructose. And fructose is something that we used to see in small amounts if we just eat an apple or just eat like a pear. But what they do now is concentrate that fructose. And because we get so much of it, that's why some people are getting heavier and having pancreas issues. That's why diabetes is going up, etc. The function of a carbohydrate is going to be quick energy. If you've ever had like low sugar spikes and then had some candy or had some piece of bread or even a potato, that's just a carb. You get a quick spike of energy, but it doesn't give you that long lasting sort of energy, and that's why you need proteins. So if you mix carbs and proteins together in your diet, you do really well. If you're just having carbs throughout the day, you'll probably notice that you're going to have these peaks and valleys of energy all day, and peaks and valleys of even mental energy all day. And it's because carbs are sort of a quick boost of energy, but that's about it. Every time I think about carbs, I think about that little button. If you've ever seen those little racing car shows where they hit this turbo boost button and they kind of have this really quick energy, but it burns out after 15 seconds. That's kind of a carb. If you need that long-term energy, that's going to be proteins, but we'll talk about them soon. Sugars can be broken up into two types. Mono always means one. Saccharide means sugar, so it's one sugar. And it's usually 5 or 6 carbon structures that come together and usually form the structure. The one that we're really going to focus in on is going to be glucose, and you could see the formula right over here. It's C6H12O6, and that is a molecule that you're going to have to memorize because we're really going to analyze it soon and talk about where that energy actually comes from. An example of monosaccharides are going to be, you could see here that, remember how structure equals function? Well, this is glucose. Don't memorize it. Don't memorize this structure of it. Just remember C6H12O6. And this is fructose. And you can see that there's some slight differences, especially near the top. And those two differences kind of tell our body, yes, glucose, I know what to do with this one, or fructose, I know what to do with it, but if you get a large amount of it, it sort of freaks out a little bit and sort of floods the bloodstream. But we'll talk about that more when we get to the digestive chapter and if you take Bio 202, Anatomy number 2. Disaccharides. So di means 2. So disaccharides are more than 2 sugars coming together. So if you remember back from our other video, if we want to put 2 things together, what we're going to do is do this thing called dehydration reaction, where here an OH and an H are going to be removed. And because of that, we're going to have this molecule that comes together. So here we have 2 glucoses. We want to put them together, and they become a new sugar that we call maltose. If we want to reverse this reaction, all we have to do is add the water, and what that's going to do is become that dehydration or dehydrolysis reaction. So, sorry, hydrolysis reaction. Hydro because you're adding water, lysis because you're breaking. So you're going from this 2 sugar to 2 separate sugars. So this 1 large maltose to 2 glucose, 1 to 1. So that's going to be a hydrolysis. If you want to add them together, that's going to be a dehydration reaction. And your body does this all the time. You have too much glucose in the body, it doesn't know what to do with it, it's going to make it into these larger sugars like we see on the right. You need those sugars because you need an energy or you're starting to get run down. It's going to start to break that maltose down and make it into glucose, which we can make it more available for our bodies. So we talked about glucose and we said it was C6H12O6. Fructose is also C6H12O6, but we saw that the way they come together is a little different. So where those hydrogens and oxygens are slightly different, and that really dictates their function in our body. Below, you can see a reaction. It's glucose and fructose, and you can see that they're put together. Now, if we were to break them down, because this is 2 sugars together, right, and we want to break them down, would that be a hydrolysis or a dehydration reaction? So remember, dehydration means to remove water, hydrolysis means to add water, and lysis means to break. Hopefully that clue gave you hydrolysis. And if you recall, just go back here, you can see it's the same sort of reaction. Cool. And then, so we did monosaccharides, we did disaccharides, and of course there's polysaccharides. And again, poly means many sugars glued together. This is going to be for storage of energy. So you have a bunch of sugar, we're going to store it away for later. Or it could be for immediate use if we need it right now. So you're just waking up in the morning, you run down, you have a bunch of sugar. You know, there's some sugar in your jam or there's some sugar in your bread, and that gets used up right away. And then structural support. We'll actually talk more about that when we talk about cells, but they use these sugars as kind of like little girders on the inside of the cells to sort of keep cells that specific shape. Here are some different types of sugars that you may not have actually known that are sugars, but they are. Starch, you could see that basically what it is a whole bunch of glucose molecules glued together, and that's what starch is. So the monomer, which means 1, would be glucose, but if you put them all together, the polysaccharide would be starch. And that's why we love potatoes. If you've ever taken a potato and eat it raw, it's not that sweet, it tastes kind of gross. But if you sort of sear it on both sides so it's brown, some of those sugars fall off right on your tongue, and that's why they taste sweet. So anytime you heat up a potato, a lot of these sugars are sort of loose and broken off. So when you put it on your tongue, it tastes awesome. If you were to take that same raw potato, and I don't recommend this already sounds gross, but if you were to chew it up and let it sit on your tongue, those sugars would start to slowly come off on your tongue, and eventually it would start to get sweeter and sweeter and sweeter. I only don't recommend it because it sounds gross. Glycogen is another type of sugar. Sadly, it's a long string of sugar. It's in meat, it's in muscle tissue, and it gives it support for those things. So when muscles need energy, they go to the sugar that they can use. And of course, plants use this thing called cellulose, and cellulose gives the plant structure. It is a sugar, and basically it's, again, glucose molecules stuck together, and they give it support, and it can use it as energy.